Okay, right triangle trig. SOHCAHTOA, you've seen it, you hopefully remember it, but let's review it. What it means, SOHCAHTOA, S is sine, O is opposite, H is hypotenuse, C is cosine, A is adjacent, then hypotenuse again, T is tangent, and again opposite and adjacent. So what do these things mean? Well, ladies and gentlemen, we're referring to a right triangle. And if this is the angle in question, we'll call it Greek letter theta, then this side opposite the 90 degrees is the hypotenuse. The side across from the angle, that is our opposite side. And the side touching or next to the angle right here, that is our adjacent side. So what does this mean? Well, it means that the sine, S-I-N, theta, sine of theta is equal to the opposite side divided by the hypotenuse. And the cosine of our angle theta will be the adjacent side length, that is, divided by the hypotenuse. And if you can believe it or not, the tangent of this, the tangent of theta, is opposite over adjacent. So let's stop here. Let's look at an example. Alright, example 1, right triangle. We'll call this angle theta. And let's go with side lengths of 5, 12, and 13. These are three sides that work in our Pythagorean theorem. If you don't believe me, go ahead and check it out. But let's write down what the three most common trig functions would be. So that would be sine of theta, cosine of theta, and tangent of theta. These can all be given as a ratio of these two sides. So the sine of theta, sine is opposite over hypotenuse, opposite side 12, hypotenuse 13. And for every angle, for every triangle that has sides in a ratio of 12 to 13, like this, if it was 24 over 26 or 36 over 39, this angle up here will be exactly the same size as it's now. These sides will just be much larger, but it will be a scale version of what we have. And theta remains theta for all triangles with sides of opposite side hypotenuse in a ratio of 12 to 13. So cosine theta, take a second, think about what that would be. Well, I hope that you're thinking it's going to be 5 over 13. And finally, tangent of theta. Tangent is opposite over hypotenuse. Opposite is 12. And adjacent, I think I might have said hypotenuse, but opposite over adjacent, 12 over 5. There are our trig functions. Example number 2, this time I'm going to change the game on us a little bit, and I'm going to tell you that this angle is 30 degrees. And I'm also going to tell you that the opposite side is, how about 1? The opposite side is 1. And I want to find the hypotenuse. Well, we can use the sides that we know and have along with our angle. So compared to the 30, this 1 is the opposite side. And x, the side we're looking for, that's the hypotenuse. Which trig function uses opposite and hypotenuse? Opposite over hypotenuse, that's going to be sine. So the way we set this problem up is we would say that the sine of 30 is equal to 1 over x. To solve this for x, what we need to do is get the x alone. We use our algebra skills. Well, we can do that. We multiply both sides by x. We get x times sine of 30 equals 1. Divide both sides by sine 30. And we get x is equal to 1 divided by the sine of 30. And sine of 30 is something we can calculate, and if you ever put this into your calculator, it will make me very, very sad in the very near future. But I happen to know that the sine of 30 is our good friend 1/2. So x has a side length of 2. If we didn't know that sine 30 is 1/2, if we weren't sure about that, if that was a big question mark, well, what would we do? We'd take our graphing calculator, we'd put sine 30 degrees in there, we'd push equals, and we would be done. So there is an overview of right triangle trigonometry, writing trig ratios for a labeled angle, and solving for a missing side within a right triangle. There we go. I hope that treats you very well. Have a lovely day.